Hello. In this video, we're going to look a little bit at function composition. So we have here two functions, f of x, which is equal to x squared plus 4x plus 7, and gx, which is equal to x minus 2. Now, we want to calculate fg2 and gf2, and if you notice, there's one function inside the other function. This is a little bit weird, but we're going to do our best to work at it one step at a time. And so for this first one, f and then g and then 2, this is read f of g of 2. We're going to focus on this inside part, g of 2, because I think we can calculate g of 2. To find g of 2, we simply take g of x, which is x minus 2, and plug in the number 2. So 2 minus 2, which is 0. That means this inside portion is the value 0. Well, now that we've dealt with that, I think we can find f of 0. F of 0 equals 0 squared plus 4 times 0 plus 7. 0 squared is 0, 4 times 0 is 0 plus 7, so our final answer here would be 7. All right, so f of g of 2 would be the number 7. What about g of f of 2? Go ahead and pause the video and give it a try. All right, well, first we want to evaluate that inside part, f of 2. I'll go ahead and do that in another color. So f of 2 means we have to find, well, 2 squared plus 4 times 2 plus 7. Everywhere we see the x, we replace it with the number 2. Now that's going to give us 4 plus 8 plus 7. And that's going to work out to a total of 19. Okay, so that means this inside portion is equal to 19. Now we need to find g of 19. Well, again, that means everywhere you see an x, you replace it with a 19. So 19 minus 2, which is 17. So our final answer would be 17. Now, a few things to note here. The first is that, well, I mean, these are not equal to each other. 7 is not the same as 17, and so the order we do f and g matters in this case. Just to give you an example, in regular math, right, 4 plus 3 is 7, and 3 plus 4 is 7. The order you do it in there doesn't really matter. But if you were doing subtraction, say 4 minus 3, that would give you 1. But 3 minus 4, that would give you -1, a very different answer. And so sometimes in math, when you're doing an operation, you can do it in either order. It's kind of like tomato, tomato, it doesn't matter. But sometimes the order does matter. I mean, no one says potato, potato. There's really only one way to say it. And so in this case, we do have to follow the rules, so to speak. Whenever you're doing function composition, you have to start with the inside function and evaluate it. And then you have to eventually find the outside function. So let's take a look here. We have our original two functions, and I want us to find f of g of 1, f of g of 2, and f of g of 3, just to get some practice with this idea of function composition. It's where you have one function inside of another function. Go ahead and pause the video and give it a try. All right, hopefully you've got the following numbers, 4, 7, and 12. Now I'll just go ahead and do that last one just to make sure you've got it. We find g of 3 as 3 minus 2, which is +1. Then we find f of 1, which is 1 squared plus 4 times 1 plus 7. So 1 plus 4 plus 7, which is indeed 12. Okay, so we found f of g of 1, f of g of 2, f of g of 3, and we notice that there might be a pattern here. I mean, 4, 7, 12, I mean, they're not really even or odd numbers. I mean, the first one goes up by 3, then it goes up by 5. So, I mean, is there a pattern? Maybe. Let's go ahead and try f of g of 4. We'll see if we find a pattern here. So pause the video and see if you can find f of g of 4. All right, well, hopefully you gave it a try. You should have the following. g of 4 equals 4 minus 2, which is 2. F of 2 is 2 squared plus 4 times 2 plus 7. So that's going to equal 4 plus 8 plus 7, which equals 19. So what we had here was the following numbers. We had a 4, then a 7, then a 12, then a 19. I mean, is there a pattern here? Perhaps. If you stare at it long enough, you might find a pattern. But if you don't have one yet, just keep going, because eventually we need to get all the way to f of g of 10. I mean, you could just do that one on your own if you want, but maybe you see a pattern. Let's take a look. All right, well, I know the answer is 103, but how did I come up with that? What I want us to do is calculate the question, but without having a 10. I want us to just do f of g of x. So I want us to have no numbers involved, just x's. Well, I mean, how would we do this? We know g of x normally by finding the specific number value, usually plugging in 10 or 4 or 3. But here we don't have anything. So g of x is simply equal to x minus 2. Okay, now what do we do with that? Well, our formula for fx is right here. And what this says is we need to calculate f of x minus 2. In other words, everywhere you see an x, replace it with an x minus 2. So you have x minus 2 squared, and then 4 x minus 2 plus 7. All right, let's do a little bit of algebra here. This will give us x squared minus 4x plus 4. This will give us 4x minus 8. Now, oh, these 4x's are going to cancel. That's nice. So this will be x squared. Negative 8, positive 7, that'll be negative 1. So we get x squared plus 3. And this tells us that if we wanted, there is indeed a general formula for f of g of x in this case. Given these two functions, f and g, you can have a shortcut, a quick way of calculating f of g of x. It's simply x squared plus 3. So if you need to calculate f of g of 10, you can simply do 10 squared plus 3. 10 squared is 100, so 103. And if you're curious, of course this works on our other numbers. If you go back, you remember f of g of 1 was 4? Well, of course it's 4. 1 squared plus 3 is 4. Now, this is kind of fun because if someone asks you to calculate a lot of f of g of x values, you can simply find the formula and it helps you get the numbers right away. And it's also just a really good practice when it comes to algebra. Here we have the same f of g of x, but instead of doing f of g of x, we want to calculate g of f of x. So again, go ahead and pause the video and see what you come up with. All right. Well, we take g, which we can't work on yet, and we take f, which we do know. It's given to us as x squared plus 4x plus 7. And so we put that function on the inside. Now, we calculate g of x squared plus 4x plus 7. In other words, everywhere we see an x, we replace it with x squared plus 4x plus 7. And then just minus 2 on the outside. Well, since there's really nothing to do here, I mean, those brackets don't do anything. There's nothing to multiply. We'll just have x squared plus 4x plus 5. And that's our final expression. It doesn't really get any simpler, unfortunately, but hey, we've got a general formula for g of f of x. And of course, if you notice, this is not equal to x squared plus 3, which was f of g of x. So just further evidence here that f of g of x is not equal to g of f of x. You can't flip-flop the order when you're doing function composition. Now let's go ahead and try this one. This says g of x. Ooh, that's kind of weird. Give the video a pause and try this one on your own. All right, well, g of x we know is x minus 2. So everywhere you see a g of x, first we put the x minus 2. And then we have still a g of x on the outside. And so now we have to substitute in everywhere we have this x has to become an x minus 2. Okay, so I guess we'll put an x minus 2 here. And then another minus 2 on the outside. That simplifies to x minus 4. All right, I know that one's a bit weird. Feel free to watch it again. Or we could just try f of x. So again, in this case, take f and substitute it in, and then substitute it in again. All right, here we go. We have f of x squared plus 4x plus 7, because that's what f of x is. And then everywhere we see an x, we have to replace them with x squared plus 4x plus 7. So we'll get x squared plus 4x plus 7 squared plus 4 x squared plus 4x plus 7 plus 7. So again, just really wanting you to see here that the x is right here, and it's become whatever was on the inside. And the 4x is right here, and the x has become exactly what was on the inside. The reason the 7 was just a 7 is because there's no x involved with it. Now, this is where you definitely need those algebra skills. We have to expand this whole polynomial, and it's definitely a little tricky. We have x squared plus 4x plus 7 times x squared plus 4x plus 7. And then over here, well, this isn't too bad. This is 4x squared plus 16x plus 28 plus 7. Now here, the x squared needs to multiply each term. The 4x needs to multiply each term. And finally, the 7 needs to multiply each term. So there's going to be a total of 9 terms here. X to the 4 plus 4x cubed plus 7x squared plus 4x cubed plus 16x squared plus 28x plus 7x squared plus 28x plus 49. And then plus all this other stuff here. 4x squared, 16x, and I guess I could simplify that to 35. Whew, all right, now once we simplify all of this, we'll have x to the 4. Then looks like we'll have 8x cubed, 34x squared, 72x, and 84. All right, definitely not a nice formula, but we were able to get there in the end. Let's go ahead and take some notes on this. For function composition, which is what we're working on, function composition, we have f of g of x, and usually we'll have a specific number, say f of g of 7. And the way you do this is first find g of 7, second find f of, well, let's say this equals some number, maybe 5. Well, then you find f of 5. and that equals some number, which is your final answer. All right. Why don't you try this following example? F of x is x minus 8. G of x is 3x plus 7. And first you could find f of g of 1. And then you could also find f of g of x. Here you choose your own example. So pick one from Unit 2, Worksheet 3. And for number 4, these are some things to remember. You might want to remember that f of g of x is not equal to g of f of x. And you might want to remember that this is read in English, f of g of x. All right, hopefully you enjoyed that video. And as always, thanks for watching.